solve the differential equation for f of x equals y. Okay, so we're given a differential equation. That means we're given an equation that is a derivative, and we need to solve it for f of x equals y. That's important because our final answer is going to be y equals something. And then we're going to find the particular solution that passes through the point 1, 2. And hopefully you remember that that allows us to solve for c. All right, y prime can also be written as dy dx equals 2x over y. And this is the first time that we've had a differential equation that really has both x's and y's in it. So the way that we separate this equation is we get everything with a y or a dy on one side and everything with an x or a dx on the other side. So for this particular equation, all we have to do is cross multiply. And if you cross multiply, then you'll get y dy equals 2x dx. And solving a differential equation means integrate. So I'm going to integrate. And the integral of y dy is 1/2 y squared. And the integral of 2x is x squared. And don't forget your plus c. Now technically, if you wanted to be perfectly correct, you would add a c on both sides of the equation. We'd have 1/2 y squared plus c equals x squared plus c. But since we have to solve for y, we're going to move that constant over, and if we take one constant on the left and subtract the constant from the right, we still have a constant. So I always just remember you only need to add the plus c on the x side. Okay, so then to solve for y, we would multiply both sides by 2. So we would get y squared equals 2x squared plus 2 times c. But 2 times c is still a constant, and therefore I can just say plus c. It doesn't matter that it's twice the original constant, it's still a constant. And then we would take the square root of both sides. And remember, when you take the square root of both sides, you have to remember to do plus or minus. So y equals plus or minus the square root of 2x squared plus c. Okay, so I've solved for y. But I need to find the particular solution that passes through the point 1, 2. So that means that when x is 1, y equals 2. So I'm going to plug a 2 in for y, and I'm going to plug a 1 in for x. And when I plug in a 1 for x, I get 2 plus c under the square root. Now, you just have to go with me on this. Notice that I've dropped the plus or minus. And the reason that I dropped the plus or minus is because my y value in this particular situation is 2, and that's a positive number. So 2 equals the square root of 2 plus c. If I square both sides to solve for c, then I would get 4 equals 2 plus c, so therefore c equals 2. And remember, you can't just circle c equals 2 and move on. You need to go back and rewrite your equation with the correct value of c. So the final equation is y equals the square root of 2x squared plus 2. And I know I've left off the plus or minus, but for this particular situation, y is a positive number, so I'm going to use the positive root here. If the point had been 1, negative 2, then I would have made the equation y equals the negative square root of 2x squared plus 2. So once again, I am going to rewrite y prime as dy dx. And I'm going to move everything else over to the right side for the time being. So I have 50x minus 5xy. All right, now I need to separate my variables. I can only have things with y's or dy's on the left side, and I can only have things with x's or dx's on the right side. And if you factor out 5x, then you're left with 10x minus y. I'm sorry, just 10 minus y. Okay, now I'm going to multiply both sides by dx. and I promise you'll get used to doing this. This may seem really complicated right now, but you're going to get very used to doing this. So now I have dy equals 5x times 10 minus y dx, and the last step would be to divide by 10 minus y so that everything with a y is on the left side. So if I divide by 10 minus y, that's really like 1 over 10 minus y dy equals 5x dx. So now that everything with a y is on one side and everything with an x is on the other side, I can finally integrate. All right, how are we going to integrate 1 over 10 minus y? Okay, we're going to use a natural log. The derivative of 10 minus y is negative 1 dy. If you wanted to use a u substitution, you could. U equals 10 minus y, so therefore du equals negative dy. So I need to have a negative and then a negative. Now I can go through the u substitution or recognize that what you have on the bottom, the derivative of that is up on top, so the integral is just the natural log of the bottom. So negative natural log of 10 minus y equals 5/2 x squared plus c. But we need to solve for y. First thing I would do is multiply both sides by a negative 1. So the natural log of 10 minus y equals negative 5/2 x squared. And here's a judgment call. You're welcome to write minus c, but minus a constant is really the same thing as plus a constant. Okay, for the constant, just like when we, on example 1, when we, just like on example 1, when we multiplied both sides by 2, instead of writing 2 times c, we just still wrote c. All right, the next step is going to be to change this to exponential form. So remember that natural log is log base e. So I can take e to the power of the entire right side, which would be negative 5/2 x squared plus c. So e to that entire right side equals 10 minus y. All right, now we're going to go off and talk about another property that's been a while since we've talked about. Actually, it hasn't been a while since we've talked about it. All right, back in Algebra 1, you were told that if you take something like e to the x times e to the c, if you are multiplying like bases, then what do you do with the exponents? Right, you add them. So this would be e to the x plus c power. Well, we're just going to go backwards from there. We're going to start with e to the x plus c and go backwards to e to the x times e to the c. So we're going this way. Okay, so e to the negative 5/2 x squared plus c would be e to the negative 5/2 x squared times e to the c. Okay, because you're multiplying like bases, and all you'd have to do is add the exponents. Well, e to the power of a constant, what can you tell me about that number? It's nothing more than another constant. So e to the c can be thought of as a constant, and I'm just going to put that in front and call it c times e to the negative 5/2 x squared. And that equals 10 minus y. So now to solve for y, I can subtract 10 and divide by negative 1, or I could add y to both sides and subtract the ce to the negative 5/2 x squared. Either way, you end up with y equals 10 minus ce to the negative 5/2 x squared. You're going to get a whole lot of practice on this in the next few days. Okay, so don't freak out if this was a whole lot. I just threw in a whole bunch of concepts for you, but I just need this concept to introduce this formula that we're about to use. Okay, number 3. In many applications, the rate of change of a variable y is proportional to the value of y. Okay, so what we're saying here is the rate of change of y is proportional to y. Or rate of change is the same thing as the derivative. It's saying that the derivative of y is proportional to y. And if y is a function of time, sorry, there's a typo there. If y is a function of time, then the proportionality can be written as dy dt equals k times y. So what this means is the derivative of y with respect to time is proportional to y, and that k is some constant of proportionality. And we'll worry about the k later. But right now I just want to solve for y in terms of t. So basically solve this differential equation. So the first thing is to separate the variables, and I'm going to multiply both sides by dt. So I get that dy equals ky dt. And I need everything with a y on one side and everything with the other variable on the right side. In the previous examples, that variable was x, but now the variable is t. So I'm going to divide both sides by y, and I get 1 over y dy equals k dt. And remember that k is a constant. Okay, the k could have been brought over with the y to the other side. However, the ultimate goal is to get y by itself. So my personal preference is to keep everything that's, don't take more with the y than you actually have to take. So it's okay for the k to stay over there. All right, integrate both sides. What's the integral of 1 over y? Natural log of y. And the integral of k with respect to t. Remember, k is a constant. So if we were integrating 5 dx, the integral would be 5x. So the integral of k dt is kt plus c. Don't forget your plus c. Okay, I have to solve for y. So natural log is the same thing as log base e. So I'm going to go e to the power that's over there on the right. The entire right side is the exponent. So e to the kt plus c equals y. And I did this on example 2 right here, and I forgot to mention it, but at this point I can drop the absolute values because whatever y is has to be positive, but remember that we've talked about that e to any power will always be positive. So you do not need those absolute values anymore. Y is guaranteed to be positive. Okay, and then using that property that e to the kt plus c would equal e to the kt times e to the c, I can rewrite this left side as c e to the kt equals y. And if you put y on the left side, you've got y equals c e to the kt. And that, my friends, is your exponential growth formula. And we use that quite a bit, and you've used it in Algebra 2 and in pre-calculus. It's just we said this is the formula that you have to use. But now that we know calculus, we can actually derive it from the situation. So anyway, this is used anytime the rate of change is proportional to the value of y. So think about like bacteria growing in a petri dish. That's going to be exponential growth, but the reason that it's exponential growth is the rate of change of the bacteria is proportional to how much is present. So if you just start with 2 bacteria, or 1 bacteria, I think bacteria can just split. I'm not a biology teacher. I hope that's right. So if you start with a really small amount of bacteria, then at first the rate of change is going to be really, really, really small because you don't have much going on. But once you get 1 million bacteria that are all dividing, then your rate of change is really, really big. So the rate of change is proportional to whatever amount you have present. And that's why you can use this formula right here.